What up, guys, and welcome back to Erbs class for 5 more minutes of math. Now, we're still talking functions, but more specifically today, we're talking about evaluating functions. Yeah, so evaluating functions is really just fancy math talk for, plugging in input values to find output values. Now, usually evaluating math just means we're going to get a number for an answer. So let me show you what I mean. Yeah, a problem might look something like this, right? We're going to evaluate this function. This is a function using x as the variable when x is -4. So real quick, just to remind you of some function vocabulary, that number that I'm going to put in is called an input. Yeah, remember our inputs are all domain values. Exactly right. Remember that for later. So guess what I'm going to replace these x's with? Yeah, -4, it says right there that x equals -4, so I'm going to replace every x with -4. Now, this is another way you might see this whole problem. If you see this x replaced with a number, replace every x with a number. Notice I replaced x with an open set of parentheses. Now just put that -4 in there. Let's do some math. Yeah, 3 times -4 is -12, and -12 minus 2 is -14. Absolutely. So if this was my input, guess what this is? Yes, that's my output. Now don't forget what this combination is, right? Yes, that combination is an ordered pair. That combination is a solution. If I were to graph this line, that combination will be a point on that line. Not only is it all of that, input, output, domain, range. Yeah, we're going to put all of this together. Let's try another one. Okay, good. Here's another example, and this is another way you might be asked to evaluate a function. Now, as far as function notation goes, this is my function in terms of x, and now it says f, but instead of x, it has a -2. What this means is this is my input value, but before I go putting it in, I'm going to rewrite this. Instead of x's, I'm going to leave open parentheses. Yes, just like that. Now, I chose this one on purpose because this is a trap problem. Notice I left that negative sign outside of my open set of parentheses. Exactly right. I'm going to show you why in a second. Guess what I'm putting in all of those open sets of parentheses? Yes, -2. Exactly right. Now, don't forget our PEMDAS. We got to do exponents first. So, what's -2 times -2? 4, right? But don't forget that negative sign that was out there waiting. Exactly right. And now we can continue on. -3 times -2 is? +6. Yeah, don't forget that last +6. Good, that's exactly right. So we can finalize our answer just like this. Yes, when I plug -2 into my f function, I get out a +8. Yeah, we can set up the ordered pair. We can set up inputs and outputs, domains and ranges, anything you want. But there's all the information you need. Let's try one more. Okay, they gave us another function, but now here they gave us the domain, or at least they gave us 3 values in the domain, and now they're asking us to use those to find the range. Now, if you remember the relationship, remember domains are what we put in, range is what we get out. So wouldn't I just take that, each number, and just plug them in one at a time? That's exactly right. Let's do the -3 first. Yeah, just like that. -2 times -3 is +6. And what's +6 minus 5? 1. Exactly right. When I plug a -3 in there, I get a +1 out. Yeah. I'm going to do the same thing for 0. Yeah. What's -2 times 0? 0. What's 0 minus 5? -5. Exactly right. Of course, I'm going to go ahead and do that too last. Exactly right. -2 times 2 is -4. What's -4 minus 5? Oh yeah, -9. So if I'm looking for range values, all I gotta do is plug in the domain values one at a time. Yeah, man, I hope this helps. Oh, but wait, can't forget about evaluating functions on a graph. Yeah, let's get a graph up here. Yep, just like that. So what if you were given a graph and you were asked, what's the value of my function at an input value of 4? Now remember, these input values are x values all along this axis. So if I want to know what the value of my graph is at this value, let's go to that value. Yeah, right there. So if I go to that x value and up to the graph, I bet I can just come over to the axis and find out where it hits. So when I plug in a 4 and go up to my graph, guess what the y value is that I get out? Yes. And of course it works in reverse, but it would look like this. So what value would I need to get a y value of 3? I go to my y value of 3, over to the graph and down, I get my x value, 4, exactly right. And don't forget what that is. Yeah, that's a solution. Yeah, that's a point on the line. Yes, that's a domain, a range of input and output. Okay, now I'm done. I'll see y'all next time, man. I hope this helps. Bye.